This video is presented to you by www.testprepadda.com. Dear students, in this session of isomerism, I will discuss functional isomerism and metamerism. First, functional isomerism. What is the definition? Two or more compounds having same molecular formula but different structures due to difference in the functional groups are called functional isomers, and this phenomenon is called functional isomerism. For example, consider molecular composition C2H6O. This is the molecular composition having carbon, hydrogen and oxygen. If I try to find degree of unsaturation here, formula we know, degree of unsaturation is what? Number of carbon atoms plus 1 minus number of hydrogen atoms by 2 minus number of halogen atoms by 2 plus number of nitrogen atoms by 2. So here it will be 2 number of carbon atoms plus 1 minus 6 by 2, and this value comes as 0. So 0 degree of unsaturation means no double triple bond, no double or triple bond or ring. Yeah. That means think about those structures where you have oxygen, functional group oxygen with the no unsaturation. Alcohol is there, ether is there. So for this we will try to write alcohol and ether. CH3, CH2, two carbon atoms, one oxygen. Now you can see 6 hydrogen atoms. This is one isomer of this molecular composition, that is alcohol. Similarly, I'll try to write ether. CH3, O, CH3. Here also there is no unsaturation. Here also there is no unsaturation. So these are the cases, or these are the structures which we can write with the help of this molecular composition. In a general manner, if I say, in a general manner, in place of C2H6O, you can write CnH2n plus 2O. So whenever this molecular composition is given, you can write functional isomers alcohol and ether. Now I'll take another case. Consider the molecular composition C3H6O. So first of all, we will find degree of unsaturation. Formula is here only. So number of carbon atoms is 3 plus 1 minus number of hydrogen atoms 6 by 2, and it comes as 1. 1 degree of unsaturation. So think about those functional groups where oxygen is present and degree of unsaturation 1 means 1 double bond. Although in a general manner, if I say 1 degree of unsaturation means it can have 1 double bond or it can have 1 ring. Okay, so first of all, we know that there is a functional group aldehyde where you can see C double bond O, 1 unsaturation. Now see, 3 carbon atoms are there, 3, 2, 5, 1, 6. 6 hydrogen atoms are there, 1 oxygen. So molecular composition is matching here. So this is one of the isomers. If we are able to write aldehyde, we can also write ketone. So CO position will change like this. This is another isomer of this molecular composition, that is aldehyde. This is ketone. Now what we can do, we can write alcohol and one double bond between CC. So like CH2 double bond CH, single bond CH2OH. Now you can match 3 carbon atoms and 6 hydrogen atoms, 1 oxygen. So this we can say as unsaturated alcohol. Unsaturated alcohol. Same manner, we can write ether CH2 double bond CH single bond OCH3. Okay. Now we can write cyclic ether because ring can also be there. So cyclic ether we can write like this. Here you have to write CH3, CH3, CH, CH2. So total number of hydrogen atoms will become 6 and 3 carbon atoms, 1 oxygen. We can also write one normal ring like this and outside this OH. Okay, ring indicates 1 degree of unsaturation and here alcohol has got 1 oxygen. So if you want to check total number of hydrogen atoms, CH3 here, sorry, CH2 here, CH2 here, CH here. So 2, 2, 4, 1, 5 and this hydrogen that is 6. So this is an idea that we can write different functional groups for the same molecular composition. In a general manner, if I say formula C3H6O, I can write CnH2nO. This is the general formula where you can think about aldehyde, ketone, unsaturated alcohol, unsaturated ether, cyclic ethers, like that. My point is clear. I'll take another case. Consider C3H6O2. Now two oxygen atoms are here. First of all, find degree of unsaturation. Degree of unsaturation will be 3 plus 1 minus 6 by 2 and that comes as 1. 1 degree of unsaturation. So think about those functional groups where oxygen, number of oxygen atoms is 2 and degree of unsaturation is 1. You can think about carboxylic acid. You can think about its derivative ester. So if I try to write, it will be CH3, CH2, COOH. Now match the composition 3, 2, 5, 1, 6 hydrogen atoms, 3 carbon and 2 oxygen. Now I can write CH3, C double bond OCH3. Okay, this is ester. I can also write HC double bond OCH2 CH3. So this is about carboxylic acid and ester. We can also write one aldehyde and OH at the same time. So aldehyde will cover the degree of unsaturation and extra OH will cover the number of oxygen atoms. I can also write ketone and one OH if possible. Okay, for example, CH3, CHOH, CHO. Okay, I can write CH3, C double bond O, CH2OH. Hydroxyaldehyde, hydroxy ketone. Hydroxy aldehyde hydroxy ketone. Okay, now similarly, you can write epoxide that will cover one oxygen and 1 degree of unsaturation. Remaining, you can write OH group here to cover the number of oxygen atoms. So these are the different ideas to write the functional isomers of molecular composition like C3H6O2. In a general manner, if I write, I can write formula as CnH2nO2. Okay, now I'll take another case. Now consider molecular composition C3H9n. Nitrogen is present in this molecular composition. First of all, degree of unsaturation. It is number of carbon atoms plus 1 minus hydrogen atoms by 2 minus halogen atoms by 2 plus nitrogen atoms by 2. So it will be 3 plus 1 minus 9 by 2 plus 1 by 2, and that comes as 0. 0 degree of unsaturation. No double bond, no triple bond, no ring. Now nitrogen is there, so I can simply write amine NH2. NH2. No degree of unsaturation here. Now carbon atoms 3, so longest chain I will write CH3, CH2, CH2, NH2. Now position I can change, but the functional group is same, so these two will not be considered as functional isomers, although number of isomers it will be counted. Okay, this is one, this is one. This is primary. Similarly, if I write NH2 in place of NH2, I write NH. Then I will write CH2, CH3 this side, and this side I will write CH3. This is another case. Now, I can write tertiary amine also. CH3, CH3, CH3. So these are the different functional isomers which can be written with the help of this C3H9n. If you want, you can write position isomer like this. Another case for functional isomerism, you write like nitro and nitride group. For example, C2H5NO2. This is given. You can also write this as C2H5ON. Similarly, cyanide and isocyanide, cyanide and isocyanide. For example, CH3CN, you can also write CH3NC. We can say alcohols and phenols. For example, if I write C7H8O, so I can write like this. This is alcohol. And when OH is directly attached with benzene ring, it is phenol. But at the same time, you have to write alkyl group like methyl here. Another case for functional isomerism, I can say oxime and amide. For example, if a composition is given as C2H5NO, so it will be the structure will be CH3 CH double bond NOH. This is oxime. I can write amide form of this as CH3C double bond O NH2. You can see the two have same degree of unsaturation, same number of carbon atoms, same number of nitrogen atoms, same number of oxygen atoms. Oxime and amide. Another case of functional isomerism. Similarly, thioalcohols thioalcohols and thioethers. For example, C2H5SH and CH3SCH3, as we did in case of alcohol and ether. Another you can say here alkynes and alkadienes. One triple bond is replaced with two double bonds. So these are the different cases of functional isomerism. Okay, now I'll talk about metamerism. Metamerism, two or more compounds having same molecular formula but different structural formula due to difference in the alkyl groups. Different alkyl groups around the polyvalent functional group are called metamers, and this phenomenon is called metamerism. In a simple word, I'll take O. This is divalent group. NH, another divalent functional group. I can write even this ester. Considered an example CH3, CH2, O, CH2, CH3. This is an ether. You can see this is the divalent functional group. This side you have ethyl, this side you have ethyl. Now, if I write another isomer of same molecular composition, where one side I am keeping methyl and one side I am keeping propyl. This is propyl, this is methyl. You can see around the polyvalent functional group, difference is in alkyl groups. Different alkyl groups around the poly. So these two will be considered as metamers. Okay, different alkyl groups size wise or nature wise. For example, I can also write CH3O CH CH3 CH3 isopropyl here in place of normal propyl. So these will be the metamers, examples of metamers. Another example, if I write this, you can see methyl group, methyl group. Now this is the metamerism. Similarly, I can do this, like if I place NH here, you can see methyl and propyl. So now I can write ethyl and ethyl. So these two will also be considered as metamers. So this is about the metamerism. Dear students, in the next video session, I will talk about one of the most important isomerisms, and that is tautomerism. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.